Hello, welcome to the Data channel, and you're watching Python Bootcamp for Data Professional series. And as part of this particular video, that is topic 23, so we'll be discussing about Python list comprehension. So in great detail with different kinds of examples. Because Python list comprehension is an important topic because it's most widely used. The reason is first is it's most widely used in most of the project you see wherever the Python is involved regressively. So you see Python list comprehension is are used, right? And also from the maybe from the if you are learning Python or if you are from the interview perspective or if you are want to uh, learn Python in a better way. So, or learn more about Python or master Python, right? So then list comprehensions is a must, and especially from the interview point of view, we can expect whenever there is a Python interview. So you can definitely expect some questions on list comprehensions. So definitely there are dictionary comprehensions, set comprehensions, which are similar to list comprehensions, but list comprehensions are more frequently used or asked in interviews. So that is why we want to make a particular video about Python list comprehension and cover this topic in great detail with the different varieties of how we can use the list comprehension. So before proceeding, if you are new to the channel, we would recommend you to please subscribe and also press bell button for instant notification. So let's get started. So in this particular video, what all things we can expect is first we will see the what is the purpose of list comprehension, why we really need to use it, and how we need to use it, like with a basic syntax and list comprehension with certain conditions, how we can use if conditions and all, and we can see how do we do a nested list comprehensions and how do you use a functions in list comprehensions and advanced version of list comprehensions with multiple conditions involved and list comprehension with nested conditions, right? And list comprehensions versus traditional way of creating the comprehensions. Like a traditional way of creating a loop, basically, right? And finally, we will see why list comprehensions are faster in terms of performance when you compare the performance with the traditional looping mechanism. So now let's quickly jump to the practicals and understand with practical session. And as you know, we are already using a VS Code setup with a Python installed. So if you don't know how to install Python and Python and VS Code, so we would recommend you to check our previous videos in the playlist, or you can check the description link below to install the this or you to create this setup in your machine, or you can use also choose option of your IDE. You can we are using VS Code. You can use any other IDs of your choice. Okay, and once you have this, we are using a Jupyter kind of a plugin here. So we are using a Jupyter plugin. You can extend create use that extension, right? And without any delay, we will start. So as you see, these are the topics we'll be covering in this video, right? And first is traditional looping example. So this will define the purpose, right? So why are we first of all using the list comprehension? So list comprehensions are in Python, right, provides a concise way of creating list. So if you compare this traditional example of creating a list, or looping a particular list, or using looping using list. So in when you are using list, it is actually not a list comprehension. It is not a we will not call it as a loop. But when you are doing using a normal traditional system of using the for each loop for x in range and then you traverse through that inside the for each you will actually do a you will write a code, right? So that's a traditional looping system, the rudimentary way of doing it, right? But when you do a list comprehension, it is single line. As you can see, the 3 lines code has been reduced to 1 line here in this case. Okay, so once you like execute here, like print of squares, right? So this will give the result, like it will give a square of the 0 to 9. So it is range means it is 0 to 9. So it will be 0 to 9. X is 0 to 9 and X is assigned to this, and it will give the squares of that. So the same way you can achieve using this. Here also it will create assign it to square, and by here also we will try to sprint. So it is giving the same result. Okay. So that is why we can say list comprehension is a concise way of looping, right? So that's a concise way of creating a list, we can call it as, right? So, and list comprehension are also powerful features that combines the functionality of a loop and a list builder into a single readable line of code. So it is a single and more readable line of code. If you see this one, this is not so readable. So maybe if you are from the traditional programming background, at a glance it might look simple for you. But if you start using actually list comprehensions make code more readable than actually traditional way of writing the loops. Okay. And next is the basic syntax. If you see what is the syntax, as you can see here, right? So this is the expression, what we call as the expression, and then comes for. For is again a keyword, and here item, you can have any item X, Y, Z, like anything you can write it, and then in. So then your iterable, what is iterable value, whether you want to use a list, whether you want to use a range, right? So whatever the iterable, whatever you want to iterate through, so you can give that here. Okay. And in this, so this is the definition of expression, item, and iterable. So the next is we will see an example. So this example we already saw, right? It is a square, giving a square root of it. This is the same example we saw. And next we will see list comprehension with conditions. What exactly this means. So here we didn't use any conditions, right? In this example we were just creating a for each loop, and then whatever value we are getting, we are using some applying some small transformations there. But here are expressions there, right? But here if you see we are using certain conditions here. So this is there, for x in range is there, and then you are using if conditions. Okay. So it is as good as you are writing like this. If you take a rudimentary or a normal way of coding, it is, so it is like what you will, the for each loop, right? So here you are iterating through a for each loop, then so you have to come down and it will go to there is a tab space. Okay. And then you are writing a if condition here below this, right? And then you have to close this. So here it is if condition. So as you can see, we need to do a lot of things here to kind of make it matching condition, right? So once this if condition is written, so finally we will have to write it to, like say you are creating X or events here, right? So there is something called as events dot append. You can use events dot append. So events you can create one more, like we need to initialize that events here. After that you will get events dot append. So then you will append X. So whatever the value is coming from out of this, right? So if it is not equal to 0, so then you are appending X here. Okay. So then whatever you are printing here, so if you are printing events, so then it will print events as a list. So the same thing we can do it using the list comprehension. So as you can see here, it was how many lines? It was 1, 2, 3, 4 lines. Okay. But here we are able to write the same code in one line. So that is why it is a comprehensive version or concise version of a like iterating through list. Okay. And you can think of any condition. So this is just one example, right? So you can have another if condition inside this. So you can have nested if conditions. Okay. Or any other type of conditions you want to use, else conditions. So you can have any kinds of number of conditions here. So then like we have a next example is create a list of even numbers, right? So this is what we have seen now. Okay. And next we will see nested. So we have previously we have seen list comprehension with conditions. So now we will see nested list comprehension. That means comprehensions inside comprehensions. So that means loop inside loop. So how that looks is, so you can see there is one for loop and one for loop group here, and there's one more for loop group here, and each group is having a item and iterable value in each of them. So there is and then finally we have an expression. So if you want to take an example, right? So this is what it is, looks like, right? So we have a coordinates. It is like a nested for loop. So this is for loop inside for loop, right? So if you want to make it the same in the rudimentary of way of implementing it, it might look something like, so you will define expressions here as an empty list, and then so you have item one equal to then this. So this is a syntax, right? But this is an example of it. So if you want to implement the same example using rudimentary way of doing it, how it will be like is coordinates. You will define the coordinates here, and then so we will have this for each condition first, right? We'll take both here, and then inside this for each there is one more for each, and then once this for each opens, so inside this one you are writing the I comma j. So where you are writing I comma j to coordinates, append I comma j. So if you are printing this one, as you can see, it is giving the coordinates, right? So coordinates means it is like for loop inside for loop, right? It is like 0 0 0 1 0 2 0 1 0, okay? Because it is ranging from 0 to 3, so it will just iterate those values here, okay? One by one, it's like a nested for each. So the same thing we can do something like this using this kind of, but again you can see here it has taken like 4 or 5 lines, but here it is only one line. So that is the beauty of using list comprehensions. And imagine, right? So there it is a simple example. So there might be a very complicated uh, like comprehension, right? It might be this longer from here to here also, like, and it might be double of this. And same thing if you want to implement in the normal for each loop, it might be like of 8 to 10 lines, but here it is just, it will be just one line. So as the complexity increase, so it will be more readable. List comprehensions will be more readable and easy to understand, easy to implement, and it will be very intuitive for the developer to understand. Okay, maybe it is little difficult at a starting if you are non-developer, but as you get used to it, it will be very easy. And next, let us see functions, using functions in list comprehensions. How can you use functions in the list comprehensions and convert a list of temperatures from Celsius to Fahrenheit? So that would be example here, right? So as you can see, we have taken one Celsius temperatures, and we want to convert this temperatures from Celsius to Fahrenheit. Okay, so this is a function I have created. Wherever I have a conversion formula here to convert the Celsius to Fahrenheit. Whenever I pass the Celsius here, it will give me the Fahrenheit value of that. So here, what I will be doing is I will be just calling list comprehension here, right? So for, like, there is a iterable value and iterator, okay, and this iterator, okay, temp, here I'm calling temp, you can call it as x y z whatever, and that I'm passing it to this function here in the left hand side. So, and this function will be called and it will return a value, right? And I'm taking that value to the temperature, Fahrenheit temps here. So then finally, if you see, it is giving me the list of converted values of this particular list. Okay, we are using comprehension, and it will just convert all this list into another new list, which will be converting all the Celsius to Fahrenheit. So this is how we use the function. So please note, the function should be added before for each loop. Okay, and you can pass the argument of the same whatever is been iterable value here, which is coming here in the for. Okay, And then we will think of advanced list comprehension with multiple conditions. So we've already seen, right? So we can use one condition. Similarly, you can use multiple conditions. It is like condition inside condition. It's like a nested condition. Okay. So here we are saying we are dividing it by 2 equal to 0. That means it's even number and it should be greater than 0. Both the conditions we are checking, right? And when you execute that, so as you can see, it should be even number and it should be greater than 0. So that's why it is taking this value, and you can give greater than say 5. So that is why it is taking now 36 and 64 only. Okay. So it's getting a square roots, I mean even squares here. Squares for even numbers basically, right? And so next is we can have a list comprehension with nested conditions. So again, these are just different flavors of using it. So here we are using nested for each loop, and then in that you are using again a condition. Okay, and what is that we are trying to achieve here? We are having a nested list, I would say, right? So this nested list, which is a 2D list, we can say, because it is having multiple elements, it's nested one, right? We can want to convert this or flatten it, okay, into a single list. Okay, so flatten a matrix list of to filter out the even numbers, and then we are filter outing only the even numbers here. We are taking only the even numbers after flattening. So this entire 2D or 3D list, what we can say, is flattened here, and we are taking only the even number. Okay, so if you just remove this condition, okay, it'll give the all the numbers here by flattening it. But our intention was to get the even numbers and flatten them. So here it is. And now let us see little more practical versions of it. So suppose we have a numbers, right? So say like we have a numbers of 1 comma 2 comma 3 comma 5 comma 6 comma 122 comma 123. So now if you try to execute this, it is filtering the records which are greater than 10 here. So now if I print, so it is giving me records which are greater than 10. Okay, you can give greater than 0 also. And then if I have a negative values here, maybe I'll make minus 122, minus 120, yeah, minus 6. So now you can see all the positive values it is giving me because I have given here x greater than 0, right? And another scenario might be like you have a list of names and you want to convert all the names to upper cases. And here you want to apply this function upper to all the elements in that list, right? Not on one or two, right? So then I have a list here. So in this list I can have the data is another name, and you have channel. Okay, so now if I print uppercase, so it will give all the characters or all the elements in that particular list. So all each and every characters is uppercase now. Okay, so now we have flattened list, nested list, and so we are again, this is a simple example we've already seen. We are trying to flatten the 2D list to a single element, a single list. Okay, flattened list. So this, so in this case, you can see we are using a nested list here. So this is a list inside list, and this list is having 3 elements, and each elements again is having three elements inside, right? So we are able to flatten that list using this kind of a syntax. Okay, we have a nested list here, so this nested list is there, and this is giving the output to sublist, and then it is going to sublist, and then it is giving the output to this for each, and this item is given as a return value. So finally, before for whatever you see, right, that will be the return value. So that is what you have to fetch in the deepest for each loop or deepest condition. That means at the end. Okay, so that is why we are able to return this item to here. Okay, and that is why we are able to flatten this two-dimensional into single-dimensional. And so the next important thing is to understand basically is to kind of understand the performance aspect of the list comprehensions, which is very crucial because uh, you might wonder how the performance will differ when you're using the list comprehension versus a traditional way of implementing it. Definitely, list comprehension will give you the more advanced or more optimized. It's actually it's optimized code. That's why it will be much more faster, right? And so why it is faster is it is optimized. Why list comprehension is faster is because it uses the optimized bytecode. That means bytecode generated by list comprehension is more efficient and has fewer instructions compared to the traditional for each loop. Because whenever your compiler run, right, so compiler will actually convert your code into bytecode, right, and then that bytecode, if it is having a if it is more efficient, right, or if it is having a less instructions for the computer to or for a program or a machine to execute, so in that case it will be obviously more faster than the normal way of looping, and it is having a reduced overhead. So that means list comprehensions reduce the overhead of the function call. For example, you are using append, right, so that will reduce that overhead that are typically necessary in traditional looping. And other reason is C level efficiency. The underlying implementation is using a C implementation in using that C Python, so you can directly manage memory and perform operations more efficiently than equivalent operations written in pure Python. So what we are seeing is traditional loops, whatever you do, that will be actual Python code when it converts, when it is trying to convert it. But when you are using the list comprehension, the internal implementation, okay, that is written in C Python. So that is why it is more closer to the machine level language. That's why it is faster. And if you really want to compare the performance, right, we can see that in a practical example here. So we can see the traditional versus list comprehension. We are taking a time library to measure. So in the first case we are using the traditional loop, and in the second case we are using the list comprehension loop. And let's try to execute this. And as you can see, the traditional has taken like 0.49, okay, and the list comprehension has taken 0.24, which is almost half of it, okay. And here you can see we have taken a range of say 1 million or something. So you can imagine if you take 1 billion or 10 billion, so this even might the difference even might increase actually. So the list comprehension might be taking 0.03, and traditional might be taking zero point 0.9 or like 1.0 seconds, whatever, right? So end of the day, we want to just demonstrate here why the traditional loops are slower, right, compared to the list comprehension loops. So here now you can understand clearly that list comprehension are not only making the developer's life easy and by making it more readable, but also it is helping the machines to perform better, and it is and ultimately increase the performance of your code that you are writing, right? So in most cases you will find that the list comprehensions is faster due to this particular reason, okay. And list comprehensions in Python benefits from implementation that leverages C for optimized performance that we have already explained, and that is the reason it is faster than equivalent constructs written in pure Python. Okay, and hope whatever we have explained in this particular video, right? So considering all these topics, okay, so all these topics were covered in this particular video, and hope this was definitely useful, and we would recommend you to practice. And if you have any questions, we would recommend you to please comment in the comment section. We will try to answer as soon as possible. So hope it was useful. Thanks for watching.